I'm going to go to chapter 3 and share chapter 3 and start from where I ended last class period. All right? Can you see my page on chapter 3, chemical bonds?
Yes.
All right. We went over octet rule last time and described two major types of chemical bonds, ionic bonds and covalent bonds. And we also discussed about, we went over octet rule and described about types of chemical bonds, ionic bond and covalent bond. We also described how periodic table is used to figure out, based on electronegativity, type of the bond formation. Ionic bond, how it's formed based on electronegativity difference of two elements making the bond. So we go on over it. I'm going to go to the last slide that we went over, maybe a couple of slides before that. We talked about monoatomic cations and monoatomic anions, how they are formed and how they are named in previous slides. Now we need to know polyatomic names of polyatomic ions. This table lists the names of polyatomic ions. Except ammonium ion, which is a cation. Rest of the ions listed the polyatomic anions. Anion is a negatively charged ion. So you need to know what is hydroxide ion. Hydroxide is this. Nitrite is this. Nitrate is this. Acetate ion is this. Perchlorate is this. Cyanide ion is this. Permanganate ion is this. You have to go to this table and memorize the formula and the name. Chromate, dichromate, and hydrogen carbonate. Hydrogen carbonate, when it loses hydrogen, one hydrogen plus, it becomes carbonate ion. Sulfide is SO3 2-. Just like hydrogen carbonate, hydrogen sulfide is when sulfide react with one proton, you get hydrogen sulfide. Common name for these are given in parentheses: bicarbonate, bisulfate, bisulfide, bisulfate. Bisulfate is HSO4- hydrogen sulfate is the systematic name. Common name is bisulfate. Sometimes we use systematic names or common names. Mostly we use systematic names. Phosphate ion is PO4 3-. That's phosphate. Hydrogen phosphate is when phosphate ion react with one of the protons, just like bicarbonate formed, it creates hydrogen phosphate. It makes phosphate ion with hydrogen plus cation make hydrogen phosphate. Dihydrogen is with two hydrogens. Phosphate ion with two hydrogen make dihydrogen phosphate. You need to remember these polyatomic ions because ionic compounds are formed between monoatomic cations and monoatomic anions like chloride, bromide, as well as polyatomic ions like hydroxide ion, nitrate ion, whatever it is in the list. So let's do a few problems. The ionic, what is the charge of ions formed in the group 7A? 7A gain one electron, produce negative one anions. The charge on the negative ion is -1. That's the correct answer. From the periodic table, you can look at group number and decide whether it is forming a cation or an ion and what charge it will be formed for main group elements. Answer is C47A. 7A produce negatively charged ion. These are monoatomic ions. When you have a formula like this, you have to figure out what charge. This is a cation and an anion. Cation is written, this is cation, positively charged. That's a negatively charged. Normally in a chemical ionic compound, these charges are balanced. The sum of the positive charge on Fe2 should be equal to sum of the negative charge on O3. Fe2O3 is made up of 2 Fe ions and 3 oxide ions. Oxide is -2. Therefore, this is plus, not plus, -6. How do I get -6? 3 times -2. Therefore, this side should be +6 because these two should be balanced. There are 2 ions atoms. So therefore, Fe should be Fe3+. 2 of them make 6. Therefore, charge on the Fe, each Fe ion, cation is 3+. That is the question they are asking, charge on the ion. It should be +3. So you can do it for any other compound. For example, aluminum chloride. Aluminum is 3+. 3 chlorides multiplied by -1. This becomes 3+. This side becomes 3-. Therefore, aluminum chloride, aluminum has 3+. You can pick up any ionic compound and figure out charge on cation and anion. For number 40, question number 40, charge on the ion is 3+. Which of the ionic compounds cation contains +1 charge? You look at the periodic table. These are the cations. These are the anions. They are asking cation charge. Potassium is group 1A. Therefore, charge is +1. It loses 1 electron. Thallium is not group 1A. This should be, the answer should be group 1A. So this is group 4A or somewhere there. This is group 2A. You can look at the periodic table. That's 2A. Therefore, 1A element which makes positive 1 is only potassium. So answer is A. That's how you figure out cationic anionic charge in a given formula. Now we're going to do some naming. Binary means monoatomic. It has a, like calcium chloride, monoatomic ions, not polyatomic. What is the correct name for MgO? So normally you figure out the Mg cation name and the anion name first. Cation name is magnesium. Anion name is oxide. We talk about this. These are the choices you are given. In naming ionic compounds, we never use prefixes to indicate number of atoms. Mono means one magnesium cation. We don't use this, either on the cation side or anion side. So this one is okay, but this one is mono is used. Ionic compounds, no prefixes. Prefix is the beginning part of the name of the cation or anion. This is the correct answer, magnesium oxide. This is wrong answer. Oxygen is not, oxide ion is not oxygen. This should have been oxide. Therefore, it's incorrect. The correct answer is C. What is the correct name for barium? BaI2. That's barium iodide. Name of I minus here. Barium makes 2 plus. Iodine make 1 plus. Therefore, charge should be balanced. So anyway, we don't use prefixes. Name should be barium iodide. This one uses di prefixes. That's wrong. This one uses mono prefixes for the barium. That's wrong. This is wrong. Iodide is not iodine. So answer is B. What is the formula of compound formed by barium and oxygen? Barium is 2 plus. Oxygen is 2 minus. Therefore, you write the formula barium oxide. If the charges are balanced, you write as it is without any subscript. So this is balance as we described here. That is the formula of the compound formed between barium and oxygen, barium oxide, ionic compound. What is the correct name for KCl? K is potassium, chloride, there's no prefixes there. We don't use any name is potassium chloride. Potassium chloride is answer C. Potassium chlorine is wrong. It has to be chloride. We don't use prefixes here. That's wrong. That's wrong. That's the only correct answer. Potassium, this is wrong also. Answer is C. What is the correct formula for aluminum oxide? Aluminum is group 3A, make 3A loses 3 electrons, make 3 plus cation, chloride makes oxide. Oxide. Oxide makes 2 negative. Oxide is 6A. It gains 2 electrons. This is 6A. Oxygen is 6A. If you look at the period. So if you look at aluminum and oxide, the charges are not balanced. How you balance charge is you take the ionic charge, put it here. You take the anionic charge, cationic charge is 3 here. Anionic charge you put here. So when you do that, the charge is balanced. That means 6 plus 6 negative. 3 oxides make 6 negative. 2 aluminums make 6 plus. Therefore, answer should be ALO23. That's the correct answer. Answer is D. What is the correct name of Ba82? This is 2 plus cation, hydrogen, make hydride ion. Hydrogen is the cation here, anion here. Therefore, this should be barium hydride. Barium is here, hydride is here. So monobarium is, prefixes are not used in cation or anion. Dihydride, this prefixes is used in the anion, that's wrong. Prefixes used in both. So our answer is barium hydride. Barium hydrogen is strong. Hydride is not hydrogen. Hydride is this. Therefore, answer is C. What is the correct formula for sodium fluoride? Sodium is group 2A. Fluorine is group 7A. 7A gains 1 electron. 1A, this is 1A, 1 plus. Group 1A. Therefore, this is charges are balanced. Therefore, answer should be sodium fluoride. This is the correct answer. What is the formula of calcium fluoride and between form from element? Calcium makes calcium 2 plus. Group 2A make 2 plus cation. Fluorine makes -1, 7A. Therefore, this charge is not balanced. -1 here. Therefore, there should be 2 fluorides. You cross multiply these charges, you get CaF2. That's the correct answer. Let me show you cross multiplication. This 1 comes here. This 2 comes there. Normally, you don't write subscript of 1 in formula. Therefore, it becomes this one, CF2. The answer is B. Now we're going to name some of the polyatomic ions. Except ammonium ion, all the polyatomic ions are anions, except ammonium ion. Ammonium ion is NH4+. Most of the ion names end with 8, nitrate, sulfate. Normally, when a monoatomic ions ends in I, they are monoatomic. 8 is mostly polyatomic. That's what the question is. It's not monoatomic anion, monoatomic cation. Polyatomic cation is not end up in, it's ammonium ion. This is the polyatomic anions ends in like sulfate, nitrate. That's the correct answer to the question. C is a polyatomic cation, anion, ends in the name with suffix 8. For the polyatomic ion that contains element nitrogen and hydrogen. If you remember, this is ammonium ion in the list. This is the only one with nitrogen and hydrogen. So answer should be not hydroxide. Hydroxide is, this is ammonium ion, NH4+. Nitrate is, sulfate is SO4. I remember the list that we've gone over. So answer is B. Nitrogen and oxygen is, nitrogen and hydrogen is ammonium ion. For the polyatomic ion that contains 3 oxygen atoms. Polyatomic ion that contains 3 oxygen atoms from the list. Ammonium don't have oxygen. Therefore, it's not the answer. Hydroxide has only 1 OH. That's not good. Nitrate ion has 3 oxygen atoms. Sulfate ion has 4 oxygen atoms. Therefore, answer should be nitrate. Answer is C. Now we go on and talk about polyatomic ions. Let's look at some more examples of polyatomic ions. Hydrogen carbonate is this. Systematic name is hydrogen carbonate. We also call it bisulfate. The common name of hydrogen carbonate is bicarbonate, not dicarbonate. Bicarbide, that's not dicarbide. Bicarbonate, that's in the table that we look into. Hydrogen carbonate is same as bicarbonate. Ide is usually associated with monoatomic anions, chloride, oxide. Which of the following ions has the name polyatomic ion? If you remember, only OH oxide has that name. That's called oxide, hydroxide. Hydroxide. That's the correct answer. That's sulfate. That is acetate. Hydrogen phosphate. So it's not, this all end in 8. Hydroxide. Answer is C. The formula of the sulfate, nitrate, and phosphate. You should pick the correct naming. This is not sulfate, this is sulfide. This is not nitrate. Nitrate has only 1 negative. Phosphate has 3 negative. Therefore, that's wrong. Sulfate is correct. This is not nitrate. Phosphate is 3 negative. That's incorrect. So therefore, this total collection is incorrect. Sulfate is correct. Nitrates is correct. Phosphate is 3 negative. Therefore, that's incorrect. Therefore, total thing is incorrect. Now, sulfate is correct. Nitrate is correct. Phosphate is correct. You check in the table that we gone over. The answer to that question is D. Now, like monoatomic anions can have complicated polyatomic anions. Anions can be simple as monoatomic anions like chloride, bromide, iodide. Also, it could be polyatomic anions like sulfate, nitrate. Cations also have, cations is positively charged ions. They could have variable charges. Transition metals show variable charges. For example, ion could have Fe2 plus, Fe3 plus. So naming ions with variable charge become a problem. Transition metals as well as inner transition, lanthanide, actinide, show that more than one charge for a cation. So how do we deal with this situation when naming? Because cations with fixed charges, there's no problem. It's always one type of charge. What we do is, systematically what we do is, if ion is 2 plus, we write an ion name and put in parentheses Roman numeral 2. For ion 3 plus, we write ion Roman numeral 3 there. That is the systematic way of doing it. You put the charge after the name in Roman numeral, in parentheses. The older system was, whatever ionic charge is lower is called us. This one was called ferrous. Ferrous is the name for, Latin name for ion. Highly charged ion. It's called ferric. So you use S ending prefix or ic ending for the lower charge S ending, highly charged ion ic ending. That way we solve the problem of naming ionic compound with variable charges. Let's look at this. This is the table of cations. Two different positive ions that are variable charge ions. These are all transition metals except tin. Only main group element, these elements are found in 4A. Tin make tin 2 and tin 4. Therefore, we use same system to show tin when the ion is 2 plus. When the ion is 4 plus, we use tin 4. Same like stannous tannin. Common or older system. That's the systematic name. As I described, copper has two charges, copper plus and copper 2 plus, transition metal. These are transition metals, all these except tin. Copper 1 ion is the systematic name. Lower charge ion is cuprous. Highly charged ion is ec. Highly charged is 2 plus. So ion 2, ion 3, ferrous, ferric. Ferrum is a Latin name for iron. For mercury, Latin name is hydragyrium. That's where you got Hg. Mercury 1 and mercury 2 plus. Mercurous ion, mercuric ion. Now when naming transition metal ionic compound, we have to use these prefixes or older system as an ic system. Let's look at some example. Copper oxide is systematic name, right? Like here, using Roman numeral. Copper is 2 plus here. Oxide is 2 minus. Therefore, copper is 2. That's copper 2 plus is cupric. When the copper is 1 plus, this is 2 minus. Copper is 1 plus. Two of them make the neutral ionic compound. That's copper 1. Less charge, cuprous oxide. That's how we use it. Iron oxide, this is 2 plus. Oxide is 2 minus. Therefore, you use Roman numeral 2. That's the lower charge, is ferrous oxide. Now this one is 3 plus. Oxide is 2 minus. Therefore, iron is 3. It's a ferric. Now you got the idea to name all monoatomic ions, polyatomic ions, anions, monoatomic cations. Cations is variable charges. Which one of the cations are formed from and they have variable charges? That's the only transition metal. This is group 3A, main group. That is 1A. Variable charge ions are formed by transition metals and lanthanide, actinide, called inner transition metal. Carbon is a non-metal. Therefore, it never forms cations. Answer is B. When a name in transition metal ion with more than one common charge, the numerical value in the charge is indicated by a Roman numeral following the name. That is the correct answer. Prefix, suffix doesn't make sense. Subscript after the name, it doesn't matter. These are all wrong. Idea comes from using Roman numerals following the name of the metal. Which of the following cation has fixed charge? These are variable charges because you use parentheses. When you use parentheses after the name, that shows the charge. Fixed charges always 2 plus. You don't write the charge of the calcium. Calcium is never written as calcium 2 plus parentheses. This is variable charge. These are transition metals. Therefore, cation with fixed charge is this one. Answer is C. What is the common name? Common is us. Copper has plus 1 plus, copper has 2 plus. That is us. That's ink. Therefore, this should be ferric cuprous. Cuprous is that one. This is wrong. Copper is 8 used for negative ions. Copper ion is wrong because you have to show the charge of variable charges. Either this one or that one, but this is lower charge, therefore cuprous. Answer is D. 2 plus, same idea. It has to be cupric. Answer should be C. Which of the following is the ferric ion? This is never formed. There are only 2 here. This is never formed. Ferric is this, high charge. This is ferrous. Therefore, answer is C. Which of the following is a ferrous charge? Ferrous is lower charge. This is never formed. Only 2 charges for the ion, 2 plus and 3 plus. Therefore, answer is B. Which type of elements sometimes uses as X system in naming ion? That's the oldest system for variable charge cation. Which type of elements? Alkali metals have fixed charges. We never use. Sodium is always +1. Calcium is +2. Therefore, we never use a system. Halogens form anions. So this is only used for cations. They make anions. Noble gas never make anions or cations. This applies to transition metal. That's the correct answer. In the X system, which species is named with ic ending, highly charged ion, highly more positive ion? That is less positive. That's wrong. Anion is never using a X system. Therefore, answer is D. Now let's look at a little bit about naming and how the ionic compounds are formed. When you have sodium chloride, sodium loses the electron, and that electron is picked up by chloride. Shown here, that electron is transferred to this. then that become that. Otherwise, using electron dot symbol, that's the valence Lewis dot symbol for sodium. That's the chlorine. One of the electrons are transferred into chlorine. It becomes chloride. This is a sodium ion. This has neon electronic octet. That has argon. So collection of ions attracted by cation and ionic charges. Anionic charges are called covalent compound, ionic compound. Now, when you look at the ionic compound, they are a collection of ions. Anions are bigger, cations are smaller because they lose electron. Then it shrinks from the atom, its form. This is a cation. This is an anion. Water never would have structure like that. Water will have a molecule, collection of atoms, one species. This is millions of cations and anions making the solid. So examine the following image representing what represent the type of the compound. This is the ionic compound. Normally, covalent compound, polar covalent compound, the electropositive doesn't make any sense. These have anions and cations. This is the answer. When you see a picture with a lot of small balls and big balls, cations and anions in a lump, in a crystal, this is a regularly arranged pattern. It's called ionic compound. When you look at the formula, this is, if you count the number of cations and anions, that's 1 to 1. Therefore, this picture represents 1 to 1 cation of KBr. These are molecules, covalent compound. These are non-metal, non-metal. This is non-metal, non-metal. Ionic compounds are formed by metal and non-metal. So this represents the structure of the ionic compound, KBr. Let's do some problems for ionic compound names and formulas. Lithium bromide. Lithium bromide has lithium ions, bromide ion. Therefore, formula is lithium bromide, 1 to 1. This is how you would get the formula from, you start with name lithium bromide, how you get lithium bromide. This has barium. This should be twice to make the charge balance. That's 2 plus, that's 2 negative, 2 of them here. That's the formula of barium iodide. Aluminum sulfide. Aluminum forms 3 positive cations. Sulfur makes sulfide just like oxygen makes oxide. That's sulfur. Therefore, formula is Al2S3. This is charge balance. Plus 6 here, minus 6 here. How do I get plus 6? 3 plus multiplied by 2 is 2 multiplied, that's a charge. We don't go over this. Sodium bicarbonate is a pool chemical. You use sodium bicarbonate to reduce the pH in pools. Sodium bicarbonate ion, that's a bicarbonate. That's how you write formula of bicarbonate, sodium bicarbonate. Potassium phosphate. Now you have to cross multiply potassium. Potassium become K3. There's a 1 only here. Therefore, you don't multiply phosphate. Potassium phosphate is K3PO4. What is the correct systematic name of iron carbonate? Iron is variable. Iron is showing variable. It's a transition metal, shows variable charges. If you look at carbonate, is 2 negative. Carbonate ion has 2 negative. Therefore, Fe should have 2 plus to keep the charge balance. This should be iron 2 carbonate. Systematic name is not the common. Common name of cations are ferric, ferrous. If the question was common name of FeCO3, that B should have been the answer. But this is the systematic name. Therefore, iron 2 carbonate. Answer is D. Iron sulfate is used as a dietary intake. Which of the following correct name of the compound? This is 2 plus. Sulfate is 1 negative, 2 negative. Therefore, it should be, there's no X system. This should be the correct answer. Iron is not 3 plus. Iron need to have parentheses. This is missing here. Iron sulfate tetroxide. This is not correct name for sulfate. Therefore, answer is B. What is the correct way to write the formula of a compound formed between calcium ion and sulfate ion? Calcium is 2 plus. Sulfate ion is 2 minus. Therefore, charge balance, you don't have to cross multiply. The answer should have been COSO4. COSO4 is this. These are all wrong. The charges are not balanced. This is balanced, but we give, when you give a ionic compound formula, we give the simplest ratio. Simplest ratio is cation to anion is 1. This is 2 to 2. We normally give the simple ratio of ions, cations and anions. The answer is D. Now to summarize, if you have a formula, sodium nitrate, like here, calcium carbonate, sodium dihydrogen phosphate, ammonium hydroxide. Then I see I can uncode the name. Iron 2 carbonate, iron 3 carbonate, copper 2 sulfate, barium hydride. These are the ions, cations, positively charged ions. The names of the ion is sodium. These are main group, fixed charges, you don't use parentheses. These are transition metals, you have to use parentheses like this. Charge is the charge on the ion. Barium is the main group element, 2A. Sodium is a 1 name. Calcium is a 2A. Sodium is a 1 name. So you can get the name of the anion. Anion is negatively charged. This is nitrate from the polyatomic carbonate. This is carbonate. Dihydrogen phosphate from the polyatomic ion name. Hydroxide is OH minus. Carbonates is CO3 2 minus. This is also carbonate. sulfate hydride. So this is you combine this sodium nitrate, calcium carbonate, sodium dihydrogen phosphate, ammonium hydroxide. That's how you get the name. This is the systematic. This is the older system, ferrospheric. So now we've done the naming of ionic compound. You should be able to do problems. Some of the anions are derived from common acid. Sulfuric acid is this. Hydrochloric acid is this. Nitric acid is this. Phosphoric acid is H3PO4. When you lose 3 hydrogen, this becomes 3 minus. When you lose 1 hydrogen, it becomes 1. HCl lose 1 hydrogen ion, and -1. So most of the anions are derived from common acids. What is the name of the H2O4 acid, sulfuric? What is the name of this one, hydrochloric, nitric, phosphoric? Sulfurous is 1 less oxygen, SO3. SO4, H2SO4 is sulfuric. S means less, just like variable charges, lower number of oxygen atoms is called for common acid. Some similarity, that's not direct relationship. So sulfuric acid is C. When the name of anion is the part of the acid ends in I, that include the suffix "-us". When nitrite is this, name of the acid is nitrous acid. When the name is nitrate, it's nitric acid. So this is end in "-ite" means "-us". You have to look at the names of the cations and acid. A is the correct name. What is the formula of hydrosulfuric acid? This is sulfuric acid. This is the hydrogen hydrosulfuric acid, H2S. Okay, H2S is hydrosulfuric acid. Hydrochloric acid is HCl. What is the correct way to write the formula formed by hydrogen ions? Hydrogen ion is positive. When you combine 1 hydrogen ion, it becomes HSO4 minus. That's hydrogen sulfate. So answer is, I cannot see here. Answer is H2SO4. You guys have any question? We're going to start on covalent bonds. Covalent bonds are formed when valence electrons are shared between two elements, two atoms of two elements. For example, oxygen and hydrogen, sharing one or more pairs of electrons. This pair is shared both atoms at the same time. It fills the valence shell of each atom. Therefore, octet rule could be achieved. Octet of electron can be achieved by sharing electron. For example, hydrogen has Lewis dot symbol of 1 dot, like here. How it become a hydrogen need to be helium, 2 electrons. Helium is stable because our first shell has 2 electrons filled up. Therefore, bond is formed. Hydrogen become like helium. Therefore, covalent bond is formed, sharing between one pair of electron between 2 hydrogen. Let's see how the octet rule works for covalent compounds. Covalent compounds are formed by non-metal, 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 non-metal. All are non-metal. Metal, non-metal are forming ionic compounds. Let's see how these compounds form octet sharing electrons. For example, water is a molecule formed by two covalent bonds. Water has 3 atoms, 2 hydrogen. These electrons are shared. Now oxygen has a octet and the hydrogen has a duet. Duet is for hydrogen noble gas electronic configuration is a duet like helium. Therefore, octet rule is satisfied or noble gas electronic configuration is achieved by hydrogen becoming helium, oxygen becoming neon. So these shared electron pairs are called bonding electron pairs, bond electron pairs. Unshared electron pairs are called lone electron pairs. These two are called lone, these two are called bonding electron pairs. So you can explain between nitrogen and hydrogen. That's nitrogen and hydrogen. 3 hydrogen react with 1 atom of nitrogen, shares 3 electron pairs. This. That's the non-bonding. It was originally on the oxygen atom. Non-bonding here. So there's a 1 lone pair, 3 bonding electron pairs. So that's also an octet here around. Hydrogen add to it. Therefore, noble gas electronic configuration is achieved by hydrogen becoming helium and nitrogen becoming neon-like. Methane, which is natural gas. You have 4 hydrogens here, shares 4 electron pairs, 4 bonding electron pairs, there's no non-bonding electron pairs. Carbon has octet and hydrogen has a duet. That's how you explain octet rule in covalent compound. Now, to draw a octet diagram for covalent bonding, you follow a procedure called Lewis structure. The Lewis structure, that diagrams I shown in the previous slides showing bonding and non-bonding electron pairs are called Lewis structure. So how do you get a Lewis structure for a molecule or cation or anion? Let's see how you get it. First, you have to know, for example, water, how they are connected. Normally, atom makes most bond is oxygen. That's the central atom. Connected is how you figure out which one is in the middle, which one is in the terminal at the end. Connect that. This is single bonds. Bonding electron pairs. There are only 2 electron pairs. Non-bonding electron pairs are shown by lines, or you could write this structure like this. So This is the Lewis structure of water. Certain compounds like carbon monoxide have 4 electron pairs between carbon and oxygen. There are 2 single bonds. This is a double bond. So when 3 electron pairs are shared between 2 atoms, it's called a triple bond. So in Lewis structures, you will see double bond, single bond, double bond, triple bond, non-bonding electrons. We all talk about, in all these Lewis structures, we talk about valence electron of the atoms participating in the bonding. Single bond shares 1 pair. Double bond shares 2 electron pairs. Triple bond shares 3 electron pairs. Let's look at a problem. The Lewis symbol for this compound, that is a group 5A, 5 valence electron. It's like nitrogen, phosphorus, etc. Number of valence electron is 5, same as the group number. So this has 5 valence electron. That is the appropriate number of valence electron. You count the number of dots in the Lewis dot symbol, you get the 5. Oh, 5A. You get from the 5 there. Answer is C. How many bonds are formed by oxygen? You look at the Lewis dot structure. Oxygen has 6 electrons, 2 unpaired electrons. Therefore, number of bonds formed by oxygen is, oxygen makes 2 covalent bonds. Ammonia, nitrogen makes 3 because there are 3 lone pairs. B is the correct answer. How many total valence electrons are in the ammonium ion? If you need to get the Lewis structure of the ammonium ion, you have to count the total number of valence electrons. This is 5, group 5A. This is 1 times 4. There are 4 hydrogens. There's a charge on it. Therefore, it is losing 1 electron. Therefore, this number adds up to 5 plus 4 minus 1 is 8. That's the octet of electrons. That is 8 electrons. So you can pick up any water molecule. How many valence electrons total molecule has? 2 here from 2 hydrogen, 6 here, there's 8. You can see 8 electrons, valence electron in water as well. How many valence electrons are in this? Is 6. Bromine is 7, group 7A. When you have a negative charge, positive charge, you subtract it. When you have a negative charge, you add them. So it becomes 8 plus 6, 14. Answer is 14. So to get number of valence electrons that are present in a Lewis structure of a covalent compound is easy. Lewis structure of molecules. What is the correct Lewis structure of ammonia? Ammonia has how many valence electrons? 1 times 3. Therefore, it's 8. So connectivity is nitrogen. The atom of nitrogen makes 3 bonds. Hydrogen makes 1 bond. Therefore, number of bond middle atom should be the one with the larger number of bonds. Nitrogen is connected to hydrogen like this. Therefore, 1 electron is left over. What is the correct Lewis structure of ammonium? I wrote down here. This is wrong. This is more than an octet. This is more than a duet. These are okay. But atoms should have octet or this has only 6 electrons. This has hydrogen need to have 2. But middle atom is wrong. This is same as what I wrote here. This is 2 dots. So therefore, this is the correct answer. This the connectivity of hydrogen, nitrogen incorrect. The atom making most bond should be in the middle. The answer is C. What is the correct Lewis structure of carbon dioxide? Carbon is how many valence electrons? Group 4A, 4 valence electron, plus hydrogen is 6 valence electron, multiplied by 2 of them. So when you add them up, 12 plus 4 is 16. So carbon is making 4 bonds. Carbon normally makes 4 bonds. Oxygen makes 2 bonds. Therefore, carbon is the middle atom. Dioxide means 2 oxygen. Unlike ionic compounds, name of the carbon dioxide is carbon dioxide. There are no charges, therefore you use prefixes. This is wrong. This is wrong because you have to have 8 electron pairs. Total of 16 electrons. 8 pairs should be on the Lewis structure. This has 4 plus, this has 8 pairs. This is correct answer. This is the wrong connectivity. This one has 6 pairs. 1, 2, 3, 4, 5, 6, 7. 7 pairs. Therefore, there's no 8 pairs. This is not carbon dioxide. This is sulfur dioxide. Therefore, correct Lewis structure of carbon dioxide is this one, A. What is the correct Lewis structure of water? Water has, we already gone over this. 2 electrons plus 6 electrons, 8 electrons, 4 pairs, 4 pairs. If you look at this has 4 pairs. This is the wrong connectivity. Oxygen should be the one in the middle. Oxygen make 2 bonds. Hydrogen make 1 bond. Oxygen should be, these two are, connectivity is correct, but this one got 4 pairs of electrons. How do I get 4 pairs? This is 1, this is 1, this is 1, this is 1. 4 pairs. Therefore, answer is C. HCl is. That's pretty easy. You write down there are 4 electron pairs. Hydrogen is bonded to chlorine. That's the structure of this one. Answer is D. I'm going to stop the class for today. We'll meet on next Tuesday. Please go over the material, and if you have any questions, let me know. Are you guys still there? Can you hear me?
Yes, you have a nice day.
All right. Take care, everybody.